Attached is a magnetic toggle style fastener. This is a new fastener which is just now making its way into the marketplace as a method of attaching air intake filter screens to mechanical equipment such as rooftop units, air handlers, air intake hoods, and other mechanical systems. As you can see, this fastener has a magnet on the bottom. This is a high energy neodymium magnet, and it is held into position using a couple of rivets. On the top side we have a post, and that post basically is used to be inserted through a grommet, and then once inserted it toggles 90 degrees to lock the filter onto the fastener. The way that this particular fastener attaches to the equipment is you just simply apply it to the surround of an air intake opening, and then what you do is you bring the filter and you attach the grommet. So we're going to move up to here, and essentially it works like this. So the grommet goes right over the top and you lock it down. Now what you'll notice is that the toggle style magnetic fastener creates a bit of a standoff. It's about 1/4 of an inch right here, and that will not go away, and that's not a good thing. Air can bypass this filter screen, and by bypassing it totally defeats the purpose of having the filters on in the first place. Now this particular style fastener is being touted in the market by its manufacturer as a secure method of mounting, and we've created a little rig here that will allow you to see for yourself whether or not it is secure. Keep in mind that once these filters are attached to your mechanical equipment, then wind is going to be at its face, at its side, at its bottom. Wind will come from every direction, and if these fasteners are not securely locked in place, you will come out one day and find that your filter screens are missing, or they're totally out of position. So we're going to take a look at just how much pressure it takes to actually move these fasteners out of their position. Now keep in mind that once these things move, the new location is retained because it is held magnetically to the equipment. So we're going to come down here and see if we can get an angle, and what we've got is this is set to 0, and we're going to grab it, and we're simply going to pull straight down. And what we're going to look for right now is first movement. So here we go, pulling straight down, and we just got first movement. Let's see what that number looks like. About 2 pounds. So we're going to reset this back to 0. We're going to pull this back, and we're going to pull straight down once again. Here we go. All right, remember we're looking for first movement. All right. All right, you're right at about 3.5 to 4 pounds. We're going to reset that back to 0. We're going to put these filters back in their position, and we're going to do it one more time. Okay, again, we're looking for first movement, and there we go. And we have about 4.5 pounds. Okay, we're going to do it one more time. Now notice how these things retain their puckered location as I described earlier. That's because once they move, the magnets hold them in their position. So we're going to reset this, and we're going to pull it one more time, except this time we're going to continue pulling as though we have a sustained wind, okay, coming at a side, for example. Let's see what happens. So here we go. We're pulling, and notice as we pull, it wrinkles and it retains its position. So let's take a look at what that pull strength was. So you're at just a little bit over 10 10 pounds, but by that time it's totally failed. It has moved well beyond the fastening points and has either gotten sucked into your equipment or is blown off your machine. So you be the judge. I would say buyer beware when using this particular type of magnetic system.